Hey guys, Mark Harian here. This is the video on Graham's law, which is our final gas law that we need to make sure we know how to solve problems for. Couple of definitions before we get going on this thing. One is diffusion, and diffusion is, as it says here, the tendency of molecules to move towards areas of lower concentration until the concentration is uniform throughout. So what we're really saying is when a gas, is released from a container, like say you spray a bottle of perfume, when that gas leaves the perfume bottle, it's a liquid in the perfume bottle. It's under pressure. When it leaves, it turns to gas and it diffuses throughout the room. It spreads out. So diffusion is a spreading out of a gas. Okay. Effusion is a little bit different, but the same idea. If I've got a balloon that has helium in it, say, over time, a latex balloon, because it's got microscopic holes in it, the helium gas will effuse through the balloon. You guys notice it deflates pretty quickly, like overnight usually. If it's one of those mylar balloons that has the metallic look to it, that can hold it way longer because it has less of the microscopic holes and openings for the gas to go through. So effusion is a gas escaping a container like a balloon, for instance, okay, or a car tire that's been popped, okay, the air leaving the car tire, that's effusion, okay. So a couple definitions there. We have an equation for this. I want that on my headstone. There's an equation for this. There's an equation almost for everything in chem, but this one looks, complicated. I know some of you guys, in talking to you today on the Zoom, you were like not sure how to set this thing up, and then I get it because it can be a little difficult at times. But we have a comparison here between these two gases, and we've got a lighter gas that we put on top. We call that gas A, and the B would be the heavier of the two gases. So Graham's law is an equation that allows us to figure out how much faster the lighter gas is than the heavier gas. So lighter gases will move at a higher rate or a faster rate than will a heavier gas. So a heavier gas will take longer to diffuse throughout a room if we spray it out of a container than a lighter gas will. Okay, and we have a comparison equation here that we use. So we take the heavier gas and we put its molar mass on the top, and the lighter gas goes on the bottom of that. And so we end up with heavier gases on the top, lighter gases on the bottom. We divide those two numbers, and then we take the square root of it. And when you take the square root of that, you'll get your answer. And the answer is going to be so many times faster. And that's what we're looking for, is how many times faster is the lighter gas than the heavier gas. Okay, so that's just a real easy, what's going on there for that. Let's look at the next one. In this, we have a video demo that I want you guys to watch in the notes. I'm not going to play it here for you now, but it's really good about showing an example of this happening in real life in a lab experiment. And so definitely watch the video to see what's going on there. Between these two gases, we're looking at a demo where hydrogen chloride and ammonia are mixed together in a glass tube over time. And the first question is, which has more mass? Well, that's going to be HCl. HCl weighs, 36.5 grams per mole. Sorry about the handwriting. And so this is, let me do it up here, 36.5 grams. You can see my fingers. And ammonia weighs 17 grams. So HCl is the heavier gas, which means it should move more slowly. So just a couple of things to think of in that demo. And definitely watch that video so you can see it happening. In the video, you won't see the gases because they're clear, but you will see oops, let me turn that off real quick. You will see the gases moving towards a spot in the glass tube in that video. And we can't see the gases as they move through the tube, but we do see where they react because they form a solid ammonium chloride. When they hit each other, they react at that point, and you start getting a faint white line that forms on the inside of that tube. And as they pass each other, going this way, this one's going that way, that one's going that way through the tube, as they pass each other, they start overlapping in the ring of solid that forms in there gets bigger and bigger as they do that. Now you notice that the HCl only gets to about this spot, but the ammonia makes it further down the tube, and that's because it's lighter. HCl is heavier, so it's going to move more slowly. So they're going to meet up not in the center of the tube, but off to the one side. They're going to meet towards the side with the heavier gas, okay, in that instance. So that's what that demo is all about, just to show a visual on how those guys move through there. Okay, so then we bring it to the math and Graham's law equation. And so we have the two gases that are in the demo. The heavier of the two goes on the top, which is here, and that's going to be the molar mass of the HCl, which is this guy, the 36.5. The ammonia is on the bottom, and all you have to do is divide the two. Now you're going to divide it and get 2.15, but then you have to take the square root, and that's going to give you 1.47. That means that ammonia is the faster gas, and it's going to move 1.47 times faster than hydrogen chloride gas in that instance. So you can really see in that demo how that's happening. And here we're just calculating how much faster is it. Okay, so that's how we run a simple Graham's law problem. In the next one, I bring up, it's kind of gross, but we got to tie it to real life. And we talk about an example with flatulence, which is what comes out of us when we toot. Okay. So the average molar mass of flatulence, yes, I looked it up. Yeah, it's in my search history now. I think it's on my work computer. It's 25.6 grams per mole. That's how much a fart, if you will, weighs per mole on the average. Okay, everybody's a little bit different. It says, which will diffuse throughout a room more quickly, the gas xenon, the noble gas, or flatulence, and how much faster? So on this problem, the 131.3 grams of xenon goes on the top. That number, again, is coming from the periodic table for xenon. This one was given to you in the problem, and we put the heavier one on top, divide, we get 5.13, take the square root, and we get 2.26. So flatulence will move 2.26 times faster than xenon on the average. And you didn't know that before, but now you do. And you could show someone how to calculate it. Okay. Who said you can't use chemistry in real life? Okay. The last problem there is really what you need to be able to do. Now, if they do give you one, and there's one on problem set 5.3 that I put on Classroom for you guys, where they give you the how many times faster, and they give you helium, which weighs 4 grams, and then they don't tell you what the other gas is. So on that one, you've got to solve for X using all your math and algebra skills. So remember, if you look at this problem on the homework, to get a square root out of there, you have got to square both sides. And so if I square both sides, let me just bring it up here, we get 4 equals 4 over X. And then we solve for X by doing that. So if you see that problem on there, that is how we set that up. And I have the setup on the homework now. It's on the Google Doc if you guys look at that. So that's how we solve Graham's law problems. That is the last of our gas laws that we cover. It's good review of how to do those assignments, okay, for that, and how to do those problems in particular, okay? As always, message me on Remind, or email me, or put comments on the YouTube video if you have questions, and I will get back to them as soon as possible, okay? Have a good one.